Hola Humans, today we are going to simplify radicals with cubed roots, and those look like square root symbols, only they have a tiny little 3 in front. So if you followed my last video, the steps are very similar. The only difference is that we are going to be circling triplets. Okay, so when we look at this, we're going to first break down that number and find all the factors. We're going to order them from least to greatest, circle the triples, and then those circled numbers go outside, the loners stay inside, and anything left over we multiply. So looking at example 1, we have the cubed root of 88. So when I look at 88, I want to find two numbers that multiply to give me 88. So I can do 8 times 11. 11's prime, which means only 1 goes into 11. So I'm not going to break that one down, but I can do 8. So 8 is 4 times 2. Breaking down 4, we get 2 times 2. And now I have all of the numbers broken down. So this is what I organize. So I have 3 2s and an 11. So I have 2 times 2 times 2 times 11. And again, this is the cubed root, so I'm going to keep that little 3 here. I'm looking for triples. So here I have a set of 2s. And for every circle that you create, you write that number 1 time outside. So that 2 goes outside, and then everything else stays. So inside that cubed root symbol, I have that 11, and I am done. Looking at example 2, we have the cubed root of 54. So if you're looking at this and you're not sure what things break down 54, you can use your calculator. So you're going to start with the number that you're trying to break down, which is 54, and just begin dividing. So if I do 54 divided by 2, I get a whole number, and that's what I'm looking for. So I'm going to do 2 times 27, and we're done there. If you're not sure how to break 27 down, do the same thing. So 27 divided by 2. Oh, I get a decimal. I don't want that. I want whole numbers only. So I'm going to do 27 divided by 3 and keep going through till I find a whole number. Since we found this right away, it is 3 times 9. Okay, and then looking at those, I know 9 is 3 times 3, and nothing else can be broken down. We have all prime numbers here. So looking at this, we're going to organize them from least to greatest. And I have 1, 2, and 3 3s. So I do have something that I can circle. I have the triple 3s. And then again, for every circle that I draw, I write that number 1 time outside of that cubed root symbol. And then the only number I have left inside is a 2. So that would be my final answer here. Looking at example 3, this one might look a little scary because we have that negative sign, but for now I want you to just kind of ignore it. Okay, and we need that cube root. There we go. So for that 27, similar to what we just did in the last problem, we know that that's 3 times 9, and 9 is the same as 3 times 3. So when I look at all of these underneath the cubed root, it's almost something that I can circle, but I still have that negative right here in the front. And if I am circling a triple, they have to match exactly. And right now they do not match exactly because this one's negative and these two are positive. So the trick that you can do here is make the other 2 positive 3s negative. And now when I do this, I have 3 numbers that match perfectly. And if I multiply these, I still get negative 27, right? If you needed to check that calculator, negative 3 times negative 3 times negative 3 still gives me negative 27. So I have to remember to put those negatives there, but I never changed the value of my final answer. So now that all 3 of those match, I can bring out that negative 3. If I think about that cubed root, there's nothing else inside. There aren't any other numbers. So I don't have to actually write that symbol at all. My final answer is just negative 3. All right, looking at another one. We have 10 times the cubed root of negative 375. So looking at 375, I know that 5 can go into it. Anything that has a 5 at the end can be divisible by 5. But again, you could go through that process of dividing by 2, 3, 4 until you get there. So starting with 375 divided by 5, I get 5 times 75. 5 is prime, so breaking down 75, I see it ends with another 5, so I'm going to divide by 5 again. So I get 5 and 15. 15 I know I can break down, so that's 3 times 5. All of my numbers here are prime, so I can order those from least to greatest. And we have 1 3 and 3 5s. From here, I'm gonna just remember that I have this 10 out front and bring it down. And I'm gonna start looking for those triples. So I have my triple 5s here, and usually we're good to bring this out. But again, in this problem, we have a negative number. So if I think about having the negative here, I could leave it as -3 and bring out the 5, but we don't like having negatives left underneath the radical or the cubed root symbol in math. So instead of keeping it with the -3, I'm going to keep it with the 5 because I know 3 negatives, when I multiply them, are still going to be negative. And when I bring out that matching -5, all of the numbers left on the inside are positive. And then just another quick check. If I were to multiply what I have right here, if I do 3 times -5 times -5 times -5, I get -375, which is what I started with. So finishing it up, I see that those -5s do match, so I'm going to write that outside. And then my cubed root has a remaining 3 inside. And then I also need to remember to bring down this 10. So 10 times -5 is -50. And then we have the cubed root of 3. And that is my final answer.